makers! Today we're talking about multicolored LEDs. Our new component on the bench is our RGB LED module. Our RGB LED component has one LED in the middle that's actually three LEDs, a red, a green, and a blue. So we have three inputs and they're all tied together in one output. You can see that in the diagram right here. Let's draw our circuit on page 15 of our notebook. In order to analyze my circuit, I'm going to use this piece of hazy plastic over the top of my LED that's going to make it a lot easier to see. I'll show you how that works. If we turn this on and we turn on our red LED, you can see it's kind of difficult to see, but if we put this plastic on top, it's nice and easy to see that that's red. With our red switch in the on position, our current is going to flow from the positive side of our battery through the switch, through the red LED, and back to the negative side of our battery. If we close the green switch, now we get yellow, because now current can flow through both of them. With this guy in the open position, current can only flow to the red LED. So opening green, red plus green in our light spectrum gives us yellow. If we close blue, red plus blue makes purple. If we put red back in the open position and close green, green and blue is going to make cyan. If we add our red color to the cyan, it tries to be white. It's pretty white in the middle, but because of the positioning of our LEDs in the actual component, you can kind of see blue on the top and red on the bottom, but it's pretty white in the middle. With 3 switches, there are 8 possible combinations for the positions of the switches. That's because 3 switches, each switch has 2 positions, off and on, and 2 to the 3rd power is 8. So let's go through all those possibilities. Possibility 1, all of them off, no light, so nothing really exciting happens. Number 2, red. Number 3, green. Number 4, blue. Number 5, cyan. Number 6, purple. Number 7, yellow, and then number 8 is the whitish color. We can explore more color combinations by using potentiometers instead of switches. We're going to bring back our dimmer module from before and see what it does with our light. We have 3 colors in our RGB LED, red, green, and blue. If we use our potentiometer instead of our switch, we can vary the amount of current that's going through the LED and mix our colors differently. See how that works. Turning that on, we're in the dimmest position with all of our LEDs, and we can slide them across. That's really cool. How that goes from bluer to greener. We keep that green on, add some red. That's really pretty looking. And let's do the purple, which is my favorite color. We can think of our RGB component as like a pixel on our computer screen or our phone screen. Each pixel has RGB coming into it. If we want to make yellow on that pixel, we just increase the red and we increase the green. You can do different levels of that. It's exactly what your computer screen does when you see beautiful, beautiful images on it. It's just varying the red, green, and blue values. If you don't have 3 dimmer modules or 3 switches in your kit, you can also use page 16 to vary the colors in your LED. It's important that you don't fill in these gray circles when you're drawing this circuit. If you did, then all 3 LEDs would be on all the time and all you'd get is white. I'll put my diffuser back and turn the switch on. I can see that my LED is red, just red. If I take the component off and look underneath, my LED component is going to contact only every other circle here. So it's going to contact that one, it's going to skip that one, contact that one, and contact this one. So only my red is being energized by my battery. In the second position, rotated one circle to the right, what's going to get contacted? This one, and this one. So red will be energized and green will be energized. So I predict that my LED is going to be yellow. Let's check it out. Sure enough, it's yellow. So we can figure out what our LED color is going to be all the way around our circle by figuring out which of these nodes is energized. At the bottom of page 16, there's a spot where you can make your own color wheel. When we do that, it's important that we don't fill in every single one of these circles. If we did, then our LED would always be white. Also, it's important that we take our negative side of our battery and connect it to our center. It's also important that our positive side of our battery connects to the node of our color wheel. With this configuration, my first one is also going to be red. The next color I want is purple. So I'm going to fill in red and blue. If I fill in this one for red, and that one would be green, so that one is blue. If I put my RGB LED there, it's not going to come on because nothing's connected to the positive side of my battery. I have to leapfrog around these other circles to make that actually happen. And then I have to connect these two. Now I've made purple. That was fun! RGB LEDs are an easy way to add a bit of color to any project. As always, thanks to Circuit Scribe for sponsoring this series of educational videos. Don't forget that all of the components are for sale on the Circuit Scribe website, and you can use code BerbawyMakers to get 15% off. Also on the website is troubleshooting help if you're having difficulty with your pen or any of your components, and you can sign up for their super cool live classes. I'm Miss Berbawy. Tune in next time to build a circuit with a light sensor.